to add, uncle. Good evening to all.
Good evening, sir.
Good evening.
Good evening, sir.
Good evening, sir.
Good evening, everyone. So this is the first question for today based on the formula of the pressure exerted by a gas. So these are the values that are given. Please try to solve this one. Root means square speed is given at this temperature. Density is given. And you have to calculate the pressure. So what was the formula for the pressure exerted by a gas in terms of these quantities? Recall that formula.
1/3 rho c square.
Rho v square, not c. C is the velocity of light. It was 1/3 rho. In fact, v RMS square. Not only v, it is RMS velocity. So straight away you have to substitute the values. Rho is the density, v RMS. So both are given. And it will come out to be Newton per meter square in SI unit. And in order to convert it into atmosphere, what we will do is please solve this. Good evening, Divya. This much? I don't think so. Are you getting so many digits after 3? Jashvi? Yeah, it must be equal to 3 atmosphere only. Are you getting 3 atmosphere, students?
Yes, sir.
Yes, sir.
So D option is correct. Simple, now you just need to remember the formula. So this is the first application of this formula. Now let us see another one. So this is the theoretical one. So try to relate the question.
So option A, first word lose.
Yeah, lose.
Okay, sir.
So now try to answer this one. What do you think?
Sir, C.
Yes. Please give your answer only in chat box so that other students can also attempt the question. But otherwise, it is correct. It is C. Because when we increase the temperature, VRMS will increase. We know that VRMS is proportional to square root of the temperature. When temperature increases, VRMS increases. And if VRMS increases, pressure is directly proportional to VRMS square. So pressure exerted by the gas increases. Okay. So that's why they are saying that if they increase the temperature, the pressure will increase. Now, why it will increase? The main cause is when we increase the temperature, there will be more frequent collision. They are saying that less frequently, so it is wrong. So there will be more frequent collision between the molecules and the walls of the container. More frequent collisions. So means strike the wall more often with higher velocity. And obviously, velocity will be higher and collision will also be more, you can say, within the same time. Collisions are more and impact is more. That's why the pressure will be greater as compared to earlier. Okay. Clear?
Yes, sir.
Average translational kinetic energy is given. You have to get the pressure. And of course, volume is also given. Capacity means volume. Yes, nobody knows?
Just computing it.
Okay. No need to calculate VRMS, Siddesh. There is a direct formula. You can make it into direct formula. Yes, Shri, and your answer is correct. Rather than doing the calculations more number of times, you can make it into a single formula. See, let me tell you. This was the formula. And this is mass by volume. Am I right?
Yes, sir.
So can I write it as? What is this quantity now? Kinetic energy?
Yes, sir.
Can I write it as 2 by 3 E by V? Now substitute the values. You know E and you know V. Yes, Siddesh?
Yes, sir.
Now when you solve it, you will end up getting the option. That's how you can convert that formula. Again, based on RMS velocity. No, Divya and Arun, it's wrong. Check it once again. Question is very simple. No, Jashri. Only 3 answers have come till now. No, Jashri. It's not. No, Ritika and Tamya. Yes, Jashri. It's correct. Read the question carefully. You are not reading it properly. It's wrong, Divya and Uzma. It's only X component. For A, it's only X component, but for B, it is total. It's wrong, Tanushree. Now, first of all, mean square velocity of it is 3 kT by kT means that is Boltzmann constant. Now for gas A, it is given that X component, the mean square of X component only, it is W square. So it means total will be, if X component is W square, then Y will also be W square and Z will also be W square. So total for gas A, mean square velocity will become 3W square. And because we have taken the square, it will be 3 kT by m. Because there are 3 directions in which molecules can go now. And all the directions are equivalent for us. Okay. So if we are getting something in X direction, so same will be the thing about Y and Z. Now, what about gas B? For gas B, we already know the mean square velocity. Na? It is V square. But the mass is now, I think, 2m. Na? Yes, 2m. So it will be 3 kT by 2m. Let it be number 2 and this be number 1. So now we have to get W square by V square. Na? So dividing 1 by 2. So 3 kT by m factor will get cancelled. So this 3 will come on the right hand side. So this is the answer. 2 by 3, that is D option. Please check.
Sir, 2. अच्छा.
Yes.
No, sir, समझ गया.
Please check everyone. So read the question carefully every time. It is clearly written that in case of gas B, it is X component. In case of gas A, sorry. For gas B, it is clearly mean square of the velocity. It is total. Whereas for A, it is only X component. And temperature is same, of course, for both of them. And because we are already taking the mean, so it doesn't matter how many molecules are there. We are already taking the mean square. Okay. Clear?
Yes.
Now let us try to prove various gas laws with the help of kinetic theory of gases. Okay. So then we will discuss some more questions. So first of all, Boyle's law. So now you should know the statement of Boyle's law. Only then you can prove it. So according to kinetic theory of gases, what do we have? P is 1 by 3 mn by v RMS square, or you can simply write capital M by capital V. This is the mass of one molecule now, n is the number of molecules. So pressure is directly proportional to, we can say, mass of gas by volume, and into temperature, I can say, because V RMS square is proportional to temperature. Na? The only factor that will come from V RMS square is the temperature. Na? And of course, mass factor will also get cancelled. If we see it carefully, we are only left with a number of, you can say, number of molecules, na? Because VRMS square is like 3 kT by m. So can I write number of molecules directly? Okay. Clear? So it means P is inversely proportional to volume for constant temperature, and this is what we have for Boyle's law.
Yes, sir.
Yes, sir.
Now Charles law. Again, according to kinetic theory of gases, again same thing. Now we have to prove that V is directly proportional to T. Na? So again, can I write it as P by V? We have already proved it. Okay. So this shows V is directly proportional to T if pressure is constant. Clear?
Yes, sir.
Next was Gay-Lussac's law. So what was Gay-Lussac's law? Pressure directly proportional to T. So again, we can write the same expression. Okay. So P is directly proportional to T if volume is constant. This was Gay-Lussac's law. Na? Please check. Next. We discussed that Graham law of diffusion or not?
Yes, sir. Discuss.
We calculated the rate also, rate of diffusion.
Not calculated.
No, means the relation of the rate with the density. I think so.
You gave us a direct formula, not derived.
Yes, direct formula. How it depends upon the density.
Yes, the square root of density. Inverse is proportional to square root.
Yes, okay. Then it's okay. Then we are almost done. So these were the laws, and we are able to prove them with the help of you can say kinetic theory of gases. Okay, so we can see that these are in confirmation with the kinetic theory of gases. It means the expression obtained by us for the pressure exerted by a gas with the help of kinetic theory of gases. Okay, it is correct one. That's why all the laws they are in confirmation. Okay, clear? So that proves the authenticity of that relation, pressure equal to 1 by 3 mn by V VRMS square. In a vessel of open mouth, and when we are heating the vessel to a temperature T, earlier it was at 60 degree, then 1/4 of the air it escapes, assuming the volume to be constant, the value of P is. Volume of the vessel remaining constant. Means volume of the gas remaining constant because the gas is inside the vessel only. Na? So gas occupies the same volume as that of the vessel. It's not correct. It means in this particular question, volume is constant. Volume of the gas it is not varying at all. Or is it varying? Please tell me what is happening.
The volume of the air is changing.
Volume. Can it change? Really? You are
Maybe the pressure exerted by the air.
How?
Because the air inside the container is not the same in both the cases.
But how can you say that the pressure will change? Pressure can only change if the number of gas molecules are same. Only then, when you increase the temperature, the pressure is going to change, or decrease the temperature, the pressure is going to change. But simultaneously, when you are increasing the temperature, number of air molecules they are also reducing. That's why the pressure will remain same. So whatever pressure would have increased by increasing the temperature, that has been balanced by the release of some quantity of air. Okay.
So please repeat.
But heating something, you are heating the air. Suppose the vessel is open. Keep yourself indeed who has unmute. Why are you unmuting? Now see, we are heating the gas. Suppose the vessel is closed one. Now the gas will expand, and of course it will exert the more pressure now. But now when the vessel is open, okay, vessel is open, just like your pressure cooker. For example, the lid of the pressure cooker is open. Now you are heating the vegetables. Okay, will it result into increasing pressure? So whatever pressure is increasing, that is being balanced by the release of some quantity of air. Na? Utni air bahar nikalti ja rahi hai beta. Okay.
Yes.
So that's why they are saying that when we are heating the vessel, 1/4 of the air escapes. Why 1/4 escapes? To balance the pressure. Okay. Clear now?
Yes, sir.
So that's why the pressure is same and the volume is also same. Why volume is same? Now the remaining quantity of air, it will again distribute itself within the vessel. So earlier also it was occupying the same vessel. Now again it is occupying the same vessel. So the volume is same. Clear?
Yes, sir.
So pressure is same, volume is same. So what is changing? Temperature is changing and mass is changing. Mass of the gas, you can say, the quantity of the gas, not the volume. Mass of the gas is 3/4 of the earlier one. Clear?
Yes, sir.
So let M1 is equal to M. And T1 was 60 plus 273, that is 333. Now M2 has become M minus 1/4 of M, that is 3/4 of M. And T2 is T. Now pressure and volume both are constant. So it means M into T will be equal to constant. Mass into temperature. Okay. Mass means you can say number of molecules. Okay. Mass is according to the number of molecules. Na? So means the number of molecules are changing. Once some quantity of air it is getting outside, means we are having less number of molecules. Na? You can put it in that terms. Clear? See here. All the time we are having this factor along with temperature. Na? Okay. This is NT by V na, all the time. So this corresponds to number of molecules, or you can say mass. Because mass of all the molecules it is same. So we are left with the number of molecule factor only. Na? So either you can call it mass or the number of molecules. So it is up to you. So this says M1 T1, M2 T2. Yes, Divya and Sanju. It's correct now. So now we have to find T2. Na? So substitute the value. So T2 will be M1 by M2 T1. So M1 is M. So it will come out to be in Kelvin, and again we have to convert it into degree centigrade. It's wrong, Jashri. So 444. It's wrong, Rita.
So if we substitute 60 degrees Celsius,
You cannot. You cannot. It is wrong. We never substitute temperature in degree centigrade. It is always in Kelvin by solving the numericals.
okay, that was my error.
Only where you come across delta T, na, you can use either of the units because the difference of temperature will remain same whether you get it in degree centigrade or Kelvin. Difference is same. But otherwise, you always take temperature in Kelvin while solving the numericals. Please keep this thing in mind. Clear?
Yes, sir.
A closed vessel So you can make use of Dalton's law of partial pressure relation. P is equal to P1 plus P2. Only two gases are there. Let me give you the hint. So now we know that PV equal to nRT. And from here, P is nRT by V. So you can make use of this relation. Okay. So N1 RT by V. And because number of moles are different, the rest everything is same. Now. And how we can get number of moles?
You know the atomic mass of oxygen and nitrogen, so
Divided by molecular mass, gram molecular mass. So for oxygen, it is 32 gram. So 32 gram corresponds to 1 mole. And we are having only 8 grams, so it is 1/4 of the mole. So P is equal to M1 by M1. Can I write like this? M1 is the mass taken and M1 is the gram molecular mass. Okay. This now. So this is 8 by 32. So half, no? Because 1/4, it will become half. And it is given to be 10, no, I think. See, total pressure. Okay. So this gives us RT by V equal to 20, isn't it?
Yes.
So then it is being said that if oxygen is absorbed by introducing a suitable absorbent, so then we are left with only nitrogen. Okay, then the pressure exerted by the nitrogen will be. So then the pressure exerted by nitrogen will be this much only. Okay. When oxygen yes, P nitrogen. It is 7 by 28 RT by V. So it is 7 by 28 into 20 atmosphere. So it is 5 atmosphere. This is the answer. D option. It's D option, Sanju. Earlier you were correct.
Yes, yes, sir, sorry.
Please check everyone. Here?
Yes, sir.
No. What do you mean by degree of freedom of a gas molecule? Any idea?
number of parameters required to completely describe the motion of the gas.
Yes, number of independent parameters, not only parameters, number of independent parameters. So the degrees of freedom of a gas, of a molecule, not specifically gas, of a molecule is defined as the number of independent coordinates required to specify its position completely. Okay, number of independent coordinates. And these are very much helpful in calculating the total energy of the gas depending upon its dimensions. Okay, so let us see for various types of gases: monatomic, diatomic, triatomic, polyatomic. But for that, you need to know equipartition theorem. What is equipartition theorem? It says energy associated with each degree of freedom means all degrees of freedom are equivalent. So energy associated with each one of them, it is same. At temperature T is half kT. Now there are various ways to calculate the degrees of freedom. Actually, you can also say like this: each quadratic term in the energy expression, it corresponds to 1 degree of freedom. For example, when you are writing the kinetic energy in this manner, this is quadratic term because it is dependent on Vx square. So this corresponds to 1 degree of freedom. Okay. So each quadratic term in energy expression corresponds to 1 degree of freedom. Corresponds to 1 degree of freedom. Whether it is half mvx square or half kx square, every time you come across quadratic expression, you might have noticed this thing. potential ho, ya kinetic ho, they are always in this form. Okay, so this is another way of defining degrees of freedom. Clear? Either by the number of parameters or by the number of quadratic terms in the kinetic energy expression. Clear or not?
Yes.
And that is the reason for harmonic oscillator. Average energy is kT, not half kT, because it is having two energies, potential and kinetic. So half kT is corresponding to kinetic and half kT is corresponding to potential. So sum is kT. Okay. So it means energy of a gas is given by. It means we can easily calculate the energy of a gas if we know its degrees of freedom. Because if energy associated with each degree of freedom is half kT, then energy associated with f degrees of freedom will be f by 2 kT, na? Where f is degree of freedom, isn't it? Clear?
Yes.
Now, it means the only task we have right now is to find f. The moment we are able to get f, we will be able to get the energy and hence various thermodynamic quantities. Okay. So for monatomic gas molecules, according to you, how many degrees of freedom are there for monatomic gas molecules?
1.
There are 3.
Sir, 3.
3 dimensions, 3 degrees of freedom. Molecules can move in all the directions, x, y, z. Or in other words, you can also say like this. When the gas is monatomic, monatomic means only one atom molecule is there. So now this molecule, it is neither capable of rotating or nor capable of vibrating. Because if you rotate a sphere, then you might not be able to get the angle through which it is rotated. अगर आप sphere को rotate कर रहे हैं, if somebody is asking you that I will rotate a sphere, then after some time, can you tell me the angle through which I have rotated the sphere? Will you be able to do so? Suppose I am rotating this sphere around this axis by some angle. Okay. So will you be able to tell me that angle through which I have rotated the sphere? No, do I? ना तो आप बता सकते हैं ना मैं बता सकता हूँ. Even though I am rotating the sphere myself, still I cannot find the rotation angle because it is symmetrical. Spherical shape, it is symmetrical. Okay. So you can try it by rotating through any axis, x, y, z, any axis. So you are not able to notice any difference between the initial position and final position. So it is not capable of rotating. So the only motion associated with the monatomic gas molecule is translation. Because is it clear to everyone? Translational means they can move from one place to another. That we can notice. That earlier the molecule was here and now after some time it is here. Okay. And because there are 3 dimensions, so that's why 3 degrees of freedom. It can either go in x direction or y or z. So you will be 3 by 2 kT for one gas molecule. Now, if we are having 1 mole, we need to multiply this by Avogadro number. So CV, specific heat at constant volume. It is derivative of U, na? And what is this NA into kB? It is our universal gas constant. And you know that for 1 mole of a gas, let me write it on the next slide. For 1 mole of a gas, when we specifically consider 1 mole, then this relation is there between the 2 specific heats. Do you know? Specific heat at constant pressure minus specific heat
Yes,
only for 1 mole. Otherwise, it is R by J. Na? Only for 1 mole it is equal to R. It means Cp is Cv plus R. Na? And you are able to calculate Cv. It was 3 by 2 R. So it will become 5 by 2 R. And now we can define gamma, which is Cp by Cv. Adiabatic coefficient. Na? Equation of adiabatic gas is Pv gamma constant. Remember?
Yes, sir.
So
Yes,
that
sir.
gamma. So Cp by Cv. So it is 5 by 2 R by 3 by 2 R. It is 5 by 3. Okay. Clear? So you can see if we are able to find the degrees of freedom, we are able to find so many things. Cv, Cp, total energy, gamma. Okay. Now, next is for diatomic gas molecules. Now you will tell me how many degrees of freedom. Yes, Divya and Arun. Very good. But how 5? 3 are of course translational.
2 rotation.
Yes. 3 translational plus 2 rotational. Vibrational, they are not taken. Vibrational only corresponds at higher temperature. They only contribute at higher temperature. So, and we are considering the molecule as rigid one right now. Diatomic means 2 atoms are there. So of course they are connected. So when we are assuming that the distance between the molecules is fixed, it means it is not capable of vibrating. Okay. So we are assuming the molecule to be a rigid one. But at higher temperature, we cannot assume the molecule to be a rigid one. It is capable of vibrating. Clear? That is, we are considering the molecule as rigid. Okay. So now, how it is having 2 rotational motion? So you know there are 3 axes. Huh? Let me show you how it is having only 2 rotational degrees. So of course, this is 1 axis, this is another axis, this is 3rd axis. Huh? So of course, we can rotate this molecule either around this axis, okay, So when both the molecules rotate like this, we are able to know the difference between the initial position and final. And of course, around this axis also. But we are not able to see any difference when we rotate around this axis. This is not noticeable. For example, just I'm rotating this marker around its own axis. Then I'm not able to observe any difference. Okay, if you rotate the cylinder around its own axis, then it will appear to be identical as it was earlier before rotation. Isn't it? Please tell.
Yes, sir.
Clear? So that's why only 2 rotational degrees of freedom are there. Because the molecule, it is not capable of rotating around its own symmetry axis, third axis, you can say, or x-axis in our particular diagram. It is not capable of rotating around x-axis. So this is not possible. Of course, 3 translational are there because it can move either in x direction, y direction, or z direction. So clear to all? So that's why it is having 5 degrees of freedom. So U will be 5 by 2. Let me write it here. 5 by 2 kT for one molecule. And for 1 mole, it will be, and it becomes 5 by 2 RT. So what is CV now?
5 by 2.
What about CP then? It is CV plus R.
7 by 2.
So what is the ratio? That is gamma. 7 by 5.
7 by 5.
1.4. Clear?
Yes,
So
sir.
you can write the heading rigid molecule. Because we are considering the molecule as rigid in this particular example. But the molecule can also be non-rigid. Okay? So let us see when the molecule becomes a non-rigid. Then it will be capable of vibrating also. Okay? So non-rigid molecules. Rigid molecules. So when it is non-rigid, then how many degrees of freedom are there according to you? You will say 7, not 6. There is a reason for that. Why we are saying 7? Because energy associated with vibrational degree of freedom, it is kT, it is not half kT. So instead of considering that degree of freedom as 1, we are considering it to be 2. Because only when we multiply 2 by half kT, it will add up a factor of kT to the earlier expression. Okay? That is the reason. Otherwise, it would have been 6 degrees of freedom. But the contribution of the vibrational degree of freedom, it is kT, not half kT. So it is double of the all other degrees of freedom. So that's why instead of adding only 1 degree of freedom, we are adding 2. Clear or not?
So can you please repeat?
Energy associated with vibrational degree of freedom, it is kT. It is not half kT, and kT means 2 into half kT. So 1 vibrational energy term, it corresponds to 2 degrees of freedom. Okay? Clear? Or you can consider it by another way. Let me tell you.
9 by 7.
Yes. Please check. So you always, you might have read this expression that it is given by 3n minus c or 3p minus c in some of the books.
Yes, sir.
These are the constraints. P are the number of particles constituting each molecule, number of atoms. Isn't it? So now, because the molecule is non-rigid, so you are not having any restriction. So C is 0 now for this case. Okay, and P is 2 diatomic. So F will become 6. But out of these, if we want to write F as 6, out of these 3 are translational, 2 are rotational, and 1 is vibrational. Actually, it is like this. But vibrational has energy kT. That's why, because we are always writing U as F by 2 kT. So that's why we are writing 7 over here. But otherwise, it is like this. Okay, clear now? Clear or not? Or you can write it in write it like this. I think that will be a good idea. How can I put this? F translational by 2 kT plus F rotational by 2 kT plus F vibrational kT. Can I write like this?
Yes, sir.
Yashri, it's not clear to you? Have a look at this expression that I have written now. Is this clear to you? Please speak up or tell me in the chat box.
Yes, sir.
Yashri, I'm asking you. So, because the molecule is diatomic, so P is 2, and because it is non-rigid, non-rigid means now the distance between the molecules, it can change. At the next moment, it may be this. At the next moment, it may be this, like this. So there is no restriction on the molecule now. So that's why the constraint is 0. So when we substitute these values, we are getting F equal to 6. Now what do we mean by F equal to 6? So out of these, 3 are translational, so put it here. Ft is equal to 3. 2 are rotational, so put Fr equal to 2. And 1 is vibrational, so put Fv equal to 1. You will end up getting U equal to 7 by 2 kT. So I think this one is better as compared to earlier one. Okay. Otherwise, I think you are getting confused. that why it is 7? Because it cannot be greater than 6 according to the formula. We are having diatomic and 3 dimensions, so it should be 6, isn't it? So I think
Yes,
it's
sir. Sounds clear.
better way of expressing it. So you can do the same thing in the earlier expression also. Okay, so you can change it. Let me write. F is F translational by 2 kT plus F rotational by 2 kT, and of course F vibrational. But because it was rigid, so vibrational was 0. So it was 3 by 2 plus 2 by 2. That's why it was 5 by 2. Here, F vibrational was 0. Na? Okay.
Yes, sir.
Now let us calculate for triatomic gas molecules. So again, we are having two cases. Either they can be linear or non-linear. Linear molecules means all the molecules, they lie along a straight line, one single line, like this, 1, 2, 3. This is linear. Okay. So now how many degrees of freedom are there? How 5 are?
3 translation, 2 rotation. Rotating by initial.
Yes. So you can remember it in this manner. 3 coordinates are required for this. 3 coordinates are required for this. And 3 or 3p minus c is also there. How many constraints are there? 1 constraint, 2 constraint. Na? So how many? 7. Na? Clear?
Yes, sir.
Because when you are saying that these distances, they are fixed, when you are saying, it means out of 9 coordinates, you require only 7 coordinates. Because when you put these constraints in the form of equations, you will be having 2 equations. And out of those equations, you will be able to express other variables in the form of 2 variables. Okay? 7 by 2 kT then for 1 molecule. And for 1 mole. Okay? Clear? Clear or not?
Yes, sir.
So what about non-linear? Yes, sir. It is 6 now. Non-linear means the molecule shape can be like this. So now how many constraints are there? 3 na? 1, 2, 3. So if you make use of this expression, P is 3, C is also 3. So it is 3 into 3 minus 3, that is 6. Okay. So U will be 6 by 2 kT, that is 3 kT for 1 molecule. And it will be 3 Na kT for 1 mole. 3 RT for 1 mole. So CV, 3R, CP, CV plus R, 3R plus R, that is 4R. So gamma,
4 by 3.
4 by 3. So in general, if we have a look at the expression for F, let us see. Just in general, means I'm talking about monatomic, diatomic, and triatomic. Okay, when we don't go into detail whether the molecules are rigid or linear or non-linear, just have a look at the expression for gamma. For monatomic, it was 5 by 3, and if we calculate it in decimal, it will come out to be 1.67. Okay. Then for diatomic, it reduced to 1.4. Okay. Then for triatomic, 9 by 7. No, for triatomic, sorry, it was for non-rigid. Say triatomic 9 by 7. It is still less than 1.4. Further less.
1.2.
Yes.
1.
With increasing, and what is happening when we are increasing the number of atoms? Degrees of freedom are increasing. Na? In monatomic, they were 3. In diatomic, then 5. In triatomic, 7 and 6. More degrees of freedom are there. So with the increase in degrees of freedom, this gamma is decreasing. So it means there is some kind of inverse relation between gamma and F. Is it clear? This is the conclusion. Na?
Yes, sir.
So that we will see tomorrow, that what kind of relation is there. And of course, that relation will be very much useful for us to calculate gamma directly from F. Otherwise, we need to calculate U, then CV, then CP. Na? So there is no need to calculate these quantities. So tomorrow we will calculate, or we will devise the relation between this gamma and F. Okay, from where we can directly calculate gamma if we know F. So that's all for today, students. So we will continue tomorrow. Okay, bye bye. Take care.
Thank you,
Bye,
sir.
sir. Thank you.